Good evening, everybody. I hope that this finds you doing very well and you got out and enjoyed the nice weather today. A few students asked me to do a recording on another example from homework 4. So I'm just going to walk right through it one more time and hopefully this will help you out. This is going to be the largest question on the exam. It is a 15-point question and it's almost half of the written points. So here we go. So I'm going to do question number 5 from homework 4. Now I'm doing this again at home and I don't have the worksheet in front of me. So I'm just going to write out the problem like I have written here and talk through it, and I just might not have exactly the words you have in front of you, but I will get the same answers and get to the same place. So the first thing that you need to do is we need to write a balanced equation. So hopefully you will be able to do that now in your sleep because you guys are such pros at this. So we are going to take our barium nitrate, and we know that this is an aqueous substance, and we're going to add potassium chromate, and again this is another aqueous substance, and we are going to get barium chromate, which is going to be our precipitate. So we have a solid there, and we are going to get 2 parts or 2 moles of potassium nitrate, which is going to be our aqueous substance. Now I know it gives us some information, so let's write that down. And like I said, I don't have all the words in front of us, but somewhere it must have said that it gave us 3.50 times 10 to the negative third moles of this substance of barium nitrate, and we reacted 265 milliliters of this with a molarity of 0.0100, large M there for molarity. And somewhere it says that we want to get the grams of precipitate, and so the precipitate is the solid, so I know that this is going to be my X, and I'm going to get it to grams. Now you should be thinking to yourself, I need to find limiting reactant. I need to find limiting reactant because I have 2 reactants that I have adding, and I don't know which one is all going to be used up. So the first one that I'm going to do is, this is going to require a little more work, but I might as well start from the left to the right. So let's say I have 3.50 times 10 to the negative third moles of my barium nitrate. Now, remember, to do limiting reactant, we have to make sure that we are comparing apples to apples. And so I'm going to bring this to my reactant side, from my reactant side to my product side. So I'm going to have 1 mole of my barium chromate, and you should see that my mole ratio is the same. So that means I'm just going to again have 3.5 times 10 to the negative third moles of my barium chromate. Okay, so now I'm going to do the other one. I'm going to compare it to this, and whichever one has the least number of moles is going to be my limiting reactant. So I know that if I take molarity, which I understand molarity again is 0.0100 moles in 1 liter of solution, and that's what this means. And so I'm going to multiply by 265 milliliters, but I'm going to put it into liters, so 265 liters, and multiply that out, and I get 0.00265, and this is moles of potassium chromate. Now, I cannot compare this to this because I have apples and oranges again, so I need to get it to the same substance. But if I look, you guys can see that this is 1 barium chromate with 1 potassium chromate, and so the ratio is 1 to 1. So I do have 0.00265 moles of my barium chromate. So now I need to take a look at both of these substances and say, okay, which one is the smaller substance? Well, 3.5 times 10 to the negative third or 2.65 times 10 to the negative third. if I put them both in scientific notation, it's going to tell me that this is my limiting reactant because this is smaller. So I am going to write that over here so we have this, that this is my limiting reactant, because we are going to need to keep that in mind. Okay, so now if I want to find the mass of my barium chromate, I know that the maximum amount of this that I can make is from the smallest amount of moles that I have available, because I can't make more than the other reactant is going to allow me to do. So I just need to take this and I need to multiply it by the molar mass of barium chromate. So when I add up 1 barium, 1 chromium, 4 oxygen, I got a molar mass of 253.3 grams in 1 mole. Okay, so if I do the math of that, I am getting 0.671 to get 3 significant figures, grams of barium chromate. So hopefully I think this part is probably the easier part, that it's really review from what we've done in the past. We're just finding a limiting reactant and what's the amount of precipitate that we can use. All right, now the second part of the equation, or the second part of the question says, what is the molarity of all the resulting ions? So this is where we need to do a little more thinking. Okay, so the first thing I want you guys to do is we're going to go back to our complete ionic equations. So if I write down my complete ionic, you should remember that we are going to separate everything that is in the aqueous state. You are going to pay attention to how many ions you have of these in solution. So my barium nitrate is going to separate into its initial parts that came together to make this substance in the first place. So I have barium with a +2 charge. You can find these on your cation-anion sheet. I have 2 nitrate ions with a -1 charge. I'm going to separate the next one. I have 2 potassium with a +1 charge. And I have 1 chromate that exists as CrO4. Look it up on your gold sheet. You can see it exists as one entity. It's a polyatomic ion with a -2 charge. Then I go to the other side, and I'm not going to separate my barium chromate because that is what's making the solid. I'm going to separate my potassium nitrate because that is dissolved in my solution. So I have 2 potassium ions, and I have 2 nitrate ions. So you can see that that 2 got distributed throughout. Okay, so something that I want you guys to keep thinking about, you guys know that I'm always talking about the picture that you have in your head. And so if you think about this in terms of a beaker, that you have your beaker, I should probably draw that a little bit bigger. These big markers that I'm using here. Okay, so if I have my beaker, lovely beaker, you should see what I'm trying to draw all this on, by the way. My little bamboo pad's kind of small. Okay, so I have my beaker in here, and I am going to be making barium chromate. So I have my barium chromate solid that's sitting here on the bottom. And if we take a look at our right-hand side of our equation over here, here's my solid that I just drew. Then I have 2 potassium ions and I have 2 nitrate ions. What those are doing is they are sitting up here in my solution above the precipitate. And so I have these swimming around in here, and I want to know what is the solubility of these substances. So if they're sitting here in water, we have the solid precipitate sitting on the bottom. That's a picture you should be thinking about. But I still have things floating around above them. What is the concentration of these potassium and nitrate ions? So that's what I'm trying to do first. So if I take a look, I can see that I have been doing in all of my work that I've been finding the moles of everything that's on the left-hand side of my equation. I just think that's easier. You can write them on both sides, but you can see that some of the things are the same on both sides. So if I go ahead and take a look at the moles that I've already figured out, so I have 3.5 times 10 to the negative third moles of barium nitrate. So when that separates, I get barium ions and nitrate ions. So this is going to be 3.5 times 10 to the negative third moles of barium. Well, this has 2 of these in my formula, so that means I need to take 2 times 3.5 times 10 to the negative third moles. And let's see, when I do that, I get 0.007, and we're keeping 3 sig figs, moles. Okay, now I'm going to look up at the next one. You can see right here I have 0.00265 moles of potassium chromate. Well, how is that going to separate out? Well, I have 2 potassium, so I'm going to take 2 times 0.00265, and that's going to give me 0.0053 moles of this one. And I only have 1 chromate in solution, so that's going to be 0.00265 moles. Okay, now when I add these two things together, you can see up here, like I said, I don't have the formula in front of me or the question in front of me, so I must have not had a volume of this one over here. So I just have that I added 265 milliliters of solution. So that is what is in my beaker. I have that liquid that I just drew on the other slide, and it takes up 265 milliliters of space in my beaker. Okay, so I want to find the resulting ions. So I have this ion right here, and I have this ion right here that I need to find the concentration of, like we drew in my picture. Well, I can see I have 2 potassium ions in the same form over here. I just figured out that the molarity of them is equal to moles over liters. So I am going to do my potassium ion right now. I'm going to say that I have 0.0053 because, again, remember, even though I didn't label it, this is moles over liters. And I can change that 265 to 0.265 liters. And I am going to get the molarity. And so the molarity of that is 0.0200 molarity. Okay? Now I'm going to do the same exact thing for my nitrate ion. And so I'm just going to take the point, so this is going to be my nitrate because that's what I have on the other side. I have 0.00700 moles over the total volume, 0.265 liters, and the answer I got for that one is 0.0264 molarity. Okay, now here's where the limiting reactant part comes in. So I got to go back and I got to look up here, and I can see that I have potassium and chromium are my limiting reactants. So if I take a look down here, I have my barium and my chromate. Well, do you see how this chromate matches this chromate way down here? So I'm kind of scribbling over this. So that means that both of these, that means that all of this is being used up to make and go into my solid. So what's in excess is my barium ions. Well, I have those barium ions also floating around on the top then. In my picture here, I got to add barium ions because not all of them went into making this solid. So what concentration of that do I have left? So from there, I need to write my net ionic. So I can cancel this whole thing because I have it over here. I can cancel 2 potassium and cancel these spectators. I have it over here. So now my net ionic, and I get to use extend a page. Sorry, you guys don't have that luxury. So I'm going to write my net ionic, which is going to be barium plus 2 plus my chromate ion, and that's what went into making my barium chromate solid. So we just decided that this is my limiting reactant and all of that is going to be used up. It's going to be gone. Well, I have, let's see, I'll write it so you guys can see it. 350 moles of that, 3.5 times 10 to the negative third. And because this is my limiting reactant, all of that's being used up. That's what it means. So it is reducing by 265 moles. That's going to be 0. It's all gone. Well, I can't reduce by more than what's available, so I'm only going to be able to reduce on this side by the same number of moles. So if I subtract those two, I get 0.00085 moles. Well, if I want the molarity of that, that's my excess moles, that's what's left over, divided by the total number of liters that I still have in my solution, that is not changing. And my molarity of those excess barium ions is 0.00321 is my molarity. Okay, Now, I know this is a lot of stuff, and I'm looking, I've been babbling for 15 minutes. My goodness. I'm very sorry for that, but hopefully going through it one more time will help you walk through this problem, and you will see one of these that are on the test. So again, write a balanced equation, find the limiting reactant, find the mass of that that's available. Then write your net ionic, figure out exactly how many moles you have of each substance, and figure out your excess and find your molarity of those based on what is left in solution on your right hand side of your equation. Then you need to write your net ionic and figure out your limiting reactant. All of that's always going to be the smaller number. Subtract that out, get what's left over, put it over liters to find the molarity. Again, it's a 15-point question. I promise you I'll grade as generous as I can. Put something down on the paper and I'll give you some points, and the parts that you trip up on, we'll do some test corrections and get those points back. So no stressing out here on this Bunsen. You guys have a wonderful night, and I will see you soon.